So let's talk about cross multiplying right off the bat. So when we talk about cross multiplying, we talk about taking the numerator of one fraction and multiplying across by the denominator of the other fraction. And then the same with the other numerator and denominator. So if we wanted to set this up, if we wanted to multiply 3 times x minus 1, how would we write that?
3x minus 1.
Okay, so I like how some people said 3x minus 3. What were they doing in their head automatically? Distributing, nice. So this is 3 parentheses x minus 1 equals,
3x minus 3.
yeah, but let's set up what the other side of this equation is
4
going to be.
parentheses x plus 1.
There we go, 4 parentheses x plus 1. Now I totally respect if you guys do the distribution in your head, but some people like to see it written out, so I'm going to write it out so it's nice and clear. And now let's go ahead and distribute. So like some people said, we now have 3x minus 3 equals 4x plus 4. And if we wanted to solve that, how would we go about solving that? We could add 3, sure. Let's add 3. And that helps because now we got rid of that term. What would be another thing we could do?
Minus 3.
I heard a bunch of different voices. Go ahead, Justin.
Minus 3x.
We could minus 3x. I'm not sure if dividing by 3 is the best idea. Is there another idea, Darren?
Subtract 4x from both sides.
I like this idea the best because that's going to be the quickest solution right here. So let's minus 4x to both sides. So now we're going to have 3 minus 4 is negative 1x equals 7. And then divide by negative 1. Okay, so we get x is equal to what? Negative 7. And if we wanted to plug this back in and check if it worked, let's try it out. Let's plug in negative 7 up here for x. What's negative 7 plus 1?
Negative 6.
Negative 6. What's 3 over negative 6?
Half.
What kind of 1 half? Negative 1 half. So this side would equal negative 1 half. Now, if we plugged in a negative 7 here, what's negative 7 minus 1?
Negative 8.
Negative 8. What's 4 over negative 8?
Negative 1 half.
Negative 1 half. Does negative 1 half equal negative 1 half? Yes. So this equation works when x equals negative 7. Let's go ahead and consider that sometimes there are restrictions on x. What can x not equal here?
1 and negative 1.
Right, 1 and negative 1. Because if they did equal those numbers, what property would we violate?
I don't know, but I know it'd make it equal 0.
Why can't we, like, what can we not divide by? 0. Right, that's the property we would violate. We would be dividing by 0. So, in this case though, x is negative 7, so that's actually not a problem. But sometimes we will see examples where our solutions are the same as our restrictions, and that is going to lead to a problem for us. Let's take a look at number 2. What is the first step that we would use when we have a fraction that equals a fraction? How do we solve this equation? Cross multiply. So let's go ahead. And if you want to do this in your head, you can, but I'm going to write out all the steps here. So we're going to write this as 2 parentheses x minus 1. And if we multiply x squared minus x times 1, same thing, so x squared minus x. And what would we do next here? Distribute. Yeah. So that gives us 2x minus 2 equals x squared minus x. Does anybody know what kind of equation that is? I see a square. It's a quadratic, right? Is it the right form?
No.
What's the right form for it? What's it called? Standard form, that's right. So standard form, you will remember, is ax squared plus bx plus c equals 0. Can we put this in a standard form? Yeah, sure. Let's go ahead and try to put this in a standard form. Okay, so what can we do here to put this into standard form?
Subtract 2x minus 2
Okay, so minus the 2x
and add 2.
and add 2 to both sides. I agree with this. You know what my favorite part of that step was? We left the x squared what? Positive. It makes it so much easier if x squared is positive. So we now have x squared minus 3x plus 2 equals 0. Is that standard form?
Yep.
Sure. So if we want to solve this, we have a couple of options. What looks to be maybe the easiest option for solving this? Tyler?
AC equals B.
AC equals B equals, which is another word for what? Factoring. Right. So let's go ahead and let's factor this. Can we do this in our heads? There you go. So x minus 1, x minus 2. Because negative 2 times negative 1 is positive 2. Negative 2 plus negative 1 is negative 3. It works very nicely. And we can see some solutions right here. What would x have to equal here?
2 and 1.
2 and 1. Awesome. We found our solutions. Now we have to go back and look at the restrictions. So when we look at the restrictions, let's first look at this x right here. What can this x not equal? 1. Good. Now, if we wanted to find the restrictions on x squared minus x, what would we have to do to that denominator?
Well,
How can we break it up to see? I'm going to square root it. Go ahead, Darren.
X minus x, x plus x.
Nope, they're not perfect squares. What do you notice between x squared and x, though?
they cancel each other out.
Oh, that'd be just x.
What is there between those? Thank you, there's a GCF. So let's take out the GCF. What's left over when we take out the GCF?
X.
X minus 1. Okay. So what other restriction is there here?
0.
Good, x cannot equal 0. So don't forget, we have to sometimes factor the denominators to see what all the restrictions are. And factor could mean GCF, it could mean breaking it up into factors, could mean a lot of things. Now, let's actually pause here for a second. Does anybody notice a problem? Whoa, good. So Justin, did you hear what Selena said?
Yeah.
What'd she say?
She said there was a problem.
Well, what was the problem that she saw? Exactly, that's why I gotta listen, okay? What she said was that x equals 1 is one of our solutions, but Justin, what's the problem up here? And x can equal 1, right? So there's actually a new vocabulary word that we're gonna learn today about what happens when one of your solutions is restricted. We call that an extraneous solution. Okay? What smaller word do you see in the word extraneous up there?
Extra.
Extra. What other words have the word extra in it?
Extra.
Extra, sure. Oh, and what does extra mean?
More.
More. Okay? What other words have the word extra in it?
Extravagant.
Extraordinary. Extravagant, yeah, I hadn't thought of that one, that's good. And what does extravagant mean?
Like over the top.
Over the top, like a little bit too far, beyond. And then extraordinary also kind of means a little bit beyond. Any others? What about the movie E.T.?
Extraterrestrial.
Extraterrestrial, what does that mean?
Aliens.
Aliens, okay.
Beyond.
Out of this world.
Yeah,
Beyond the earth, right? Terrestrial means earth. So, what we're going, yes, question?
Oh, no.
Oh, okay, look like you have your hand. So extraneous means beyond. It means a solution that's beyond the scope of what's possible. So we're going to label this solution here extraneous. because it does not work. It's restricted. All right. Any questions so far on number 1, number 2?
Can you just label that?
We just label it, that's it.
I'm writing down the phone.
Yeah. Yes, you are absolutely right. So I think we have found the restrictions. X cannot equal 8, 2, and
-2.
-2. Is this a problem for us?
Yes,
two.
because of the.
Right, so what do we call this 2? Extraneous, nice. Fantastic. Any questions on 3 or 4? Let's take a look at number 5. You guys want to try this one on your own? Yeah. Let's go for it.
Yeah.
There you go. Okay, if you want to check your work with a partner, it's not a bad idea. Can I make a suggestion? Instead of dividing by 2x? Oh, no, you did fine. You just minus that, that's good. All right, let's see if we can factor that now. That looks perfect. What would you do to put that in standard form? There you go. Good.
Can you check my?
Excellent. Look for restrictions now.
Oh,
Okay, look for restrictions.
But there's no
Are
extra.
you sure? Okay, what's one of your solutions? One of your solutions? Let's take a look again.
There's no extraneous.
You're right. There's no extraneous solutions. Very good.
So when you can't factor the, it's not.
Well, are you saying we can't factor this?
No, not that I'm saying, like, when it's like this, how you can factor those if it's not there, it's not gonna be able to read that.
Correct. But I have that constantly now.
Because you cross out
You didn't put this in standard form.
-2x.
Get the minus 2x from both sides. And I'll change it.
Because one minus two.
Yeah, bring that down.
You're welcome.
Yeah, but then can't you cross out 2x right here with -2 or minus it would be actually x squared plus 3x minus 6.
The only difference is
Yeah. No, because then you have a range symbol.
only if they're the same sign. So watch this. If you minus 2x from both sides, that'll cancel out here, but then you've got -2 minus 2. So -2 minus 2.
She was like, you should have left like that.
Right, so then 2x, maybe if you take the 1x and you minus the 2x, you get a -x right there. So this is actually very well done, nice job. All right, guys, let's see if we can go through this one together now. We're gonna kind of hop around the room, get some feedback from different people. Justin, would you be so kind as to get us started? How do we start this problem? Let's give Justin our full undivided attention, please.
You would cross multiply,
Yeah?
which would be x minus 2, and then you would distribute it into x plus 2,
Yeah, good.
and equals 2x.
Perfect. And let's pick on Cassie next. What would we do next here, Cassie? We'd FOIL, good. And what will that give us? Equals 2x. And what will we do next here, Lane?
We combine 3 and -2,
Cool. And what does that give us?
x.
Good, plus x minus 6 equals 2x. And I saw some people starting to factor this expression right here. What's wrong with that?
Yeah.
Doesn't
It's not standard form.
You gotta get in standard form first. So what we do to put this in standard form? Yeah, minus 2x. There we go. So that means we have, go ahead, Bree, what do we have?
Square minus x
Yeah?
minus 6, and then equal to.
Good. Does this factor?
Yes.
How does it factor?
3, 2.
So x minus 3, x plus 2. And what are the solutions?
3, -2.
X equals 3, x equals -2. Do we have any restrictions up here? What are our restrictions?
-3, 0.
Is that a problem for us?
No.
No, because our solutions are different. Yes, go ahead, Cynthia.
I need the homework I'm leaving.
Sure, we're gonna do all the odds on that homework page right there. Okay, cool. Do we have any questions on number 5? Yes, Lane?
How do we get the restrictions, 0, -2?
Oh, basically, we start with the principle that we cannot divide by 0. Okay? So if you plugged in 0 for x right here, you would have something over 0, which we can't have. Okay? Same thing with x right there. If you plug in -3 for x right there, -3 plus 3 is equal to?
0.
Can you divide by 0?
No.
That's why it's a restriction.
Alright.
Okay? All right, let's take a look at number 6. Tyler, did you get us started? Okay. Let's take a look at the next problem. Let's go ahead and get started on cross multiplying this, huh?
You can't.
We can't.
There's a 7 in the one.
There's a 7 in the way. Haley says that we cannot cross multiply. Does anybody agree? Does anybody disagree?
Can't do that.
How would we cross multiply?
What you just have to do,
You would have to multiply each term on both sides of the equation by the lowest common denominator.
By what?
Technically, you're right, you could do it that way. That's more work, but you could do it that way. What if I told you that there's a much simpler way to solve these than to try to cross multiply here? Yes, Justin?
Never mind.
Okay. All right, now, I want to share with you what that method is, okay? It's called, as you can see on your sheet, it's called finding the LCD, the least common denominator, okay? This is one of the most elegant and helpful methods that we're going to learn in this class, okay? So let's go ahead and let's write down LCD, and let's try to figure out, if we look at that whole equation, what the LCD is for all the fractions.
Oh. 1.
So what does this fraction want for a denominator?
Oh, I am so confused.
A 2.
We have to treat this as if it's the whole thing. Yeah, that's fine.
I want this.
There's 1.
And what's x minus 2 since there is one.
I'm so confused.
Okay, let's back up. Let's back up. What is the only denominator that we see in this entire problem? X minus 2. So the least common denominator has to be x minus 2. Yeah. Okay, so for the LCD, we're going to say that it's x minus 2. Now question, for this 7 right here, what's in the denominator even though we don't put it?
1.
1. So if we wanted to, we could multiply this by 1, but is that going to change it?
No.
No. Okay, so the LCD for this whole problem is x minus 2. Now, let me ask you guys, have you ever seen a teeter-totter?
Yes.
Okay? If you want the teeter-totter to be perfectly flat, what's got to be true about that teeter-totter? The weight has to be the same. It's got to be even. Absolutely. So for example, if we had a 100-pound weight on one side of the teeter-totter, what would we have to have on the other side? Another 100 pounds. And then this would be balanced. Okay? Now what if on one side we doubled it and we put an extra 100 pounds on that side?
Then you have to double on the other side.
Then we got to double on the other side. So I think there's a rule that we come up with here that if you multiply one side of a teeter-totter by something, what do you have to do to the other side? The same thing. Now equations are just like teeter-totters. They're perfectly balanced. Okay? So if we do something to one side of an equation, if we do it to the other side, it's okay, because it'll still be perfectly balanced. Okay? Which leads us to how this trick works. The trick is basically to take this LCD, this value here, and we're going to multiply both sides of the equation by this LCD. Okay, and we're going to see what happens. So when we multiply by the LCD, we're basically going to take this LCD and we're going to write it in the numerator next to each one of the fractions. So we're going to multiply 5x times x minus 2. We're also going to multiply the 7 times x minus 2. We're also going to multiply the 10 by x minus 2. Basically, the whole equation, just like we would multiply the whole teeter-totter, we're going to multiply the whole equation by x minus 2. Now, take a look up there and try to discover what's about to happen if we do that. Nope. Just the opposite, actually. Who's that? Selena? You say it louder?
Things cancel out.
Things cancel out. Looking at this first fraction, what's going to cancel out here? The x minus 2's. Let's cancel those out. Does anything happen with the 7?
No.
No. But what about the last fraction? Does anything cancel out?
Yes.
The x minus 2's. So guys, what happened to all of our denominators? They canceled out. Let's look to see what we have left. What's left from this first fraction? 5x. And then we have an equal sign, so let's write that. And then what should we do with the 7 parentheses x minus 2? We should distribute it, absolutely. So that's going to give us what?
7x minus 2.
Nice. And what's left over in that last fraction?
Plus 10.
Plus 10. Oh my gosh, guys,
So it would be minus 1.
very close. Let's take it one step at a time. So, looking at how we started with that big equation with all the fractions, and looking to where we are now, which is a friendlier equation to solve? The one in blue or the one in green up top? This one. Much easier to solve. Okay? If we wanted to solve this equation, how would we do it? Give me some steps.
Well,
You
we
would
would have
add
to combine the like
So, combine some like terms. So,
5x equals 7x minus 4.
minus 4. Okay, what can we do next?
Minus the 5.
We could minus the 5x.
Or minus the.
Which is quicker?
Minus
Minus the 7.
7?
Yeah, because it's one less step this way. Now you just have 5 minus 7 is negative
I thought you wanted
2x.
to keep that positive.
Well, that's only for quadratics.
Okay.
For linear equations, it doesn't matter too much. And then divide by negative 2. So, x equals 2. We got our solution.
Yeah.
Yeah, what's the problem?
So the x equals.
Why can't x equals 2?
Because it can cancel out.
They would cancel out, you'd be dividing by what? 0. Can you divide by 0?
No.
No, so what kind of solution is this? Extraneous. So if a solution is extraneous and you forget to write extraneous, you will lose points on that question.
Really?
What if you can't spell it right?
That's fine.
I just put index.
That's fine. As long as you understand what the word is, that's fine. Okay. Isn't that an elegant method for solving equations? Yeah. It's kind of like transforming. You know, it's like a transformer. You take an equation that's complicated. It's got all these fractions in it. It's got all these, little hiccups, and you do one simple little trick that cancels out all the denominators. It is a very, very cool trick.
Maybe you should put out transformer pictures instead.
Oh, instead of these nature pictures? Maybe, that's a good idea.
These transform too.
Okay, so what is the first step in trying to solve this next problem, Darren?
Finding the least common denominator. which
Absolutely.
In this case is 2x.
So Darren says that LCD is 2x. Do we agree?
Yep.
Yeah, I think we agree. Because basically the first fraction asks for an x, and we give it an x. The second fraction asks for a 2. The last fraction asks for an x, but what do we tell it? We already have one. We got one, okay. So now that we found the LCD, what do we do with it?
Take it to the top.
Take it to the top, I like that, take it to the top. Is another way of saying what? multiply by the
2x.
Top part of it.
Least count.
Numerator.
numerators.
I don't know the difference.
Numerator is on top, denominator is on the bottom. Come on, guys. So we're going to multiply each of the numerators by 2x. Now, when we do that step, what's going to happen?
It will cancel out the x's.
Okay, so in the first fraction, the x's will cancel out. What's going to happen in the second fraction?
It'll cancel out
The 2's will cancel out. What happens in the last fraction?
X's.
The x's cancel out. Guys, what happened to all of our denominators?
They're
They're gone. This is a very, very useful trick. So what's left over in the numerator? 8.
plus
5x.
Negative 22.
Perfect. And which equation would you rather work with? This one down here or the one we started with?
the second
The
one.
second one for sure.
Minus 8.
We could probably solve this in a jiffy. Go ahead, nice job. Minus 8, good. You're laughing at my in a jiffy expression. It's kind of an old expression, I don't hear that much anymore. And then divide by 5? Yeah, so x equals negative 6. What should we look for next? Restrictions. So x cannot equal 0. Is this a problem for us? No. So we're good?
Okay.
We're good.
I'm gonna write that on them.
Nice.